Hi, this is Mrs. Boykin with another math video. This time we're going to be talking about radical basics. We're going to review, again, if you can copy these into your notes and bring them to class, I can give you credit for doing so. We're going to first talk about radical notation. Now, we talked about the square root when we were factoring. We talked about the cube root when we were factoring, perfect cubes. This is our radical. And of course, when we have a square root, we don't bother to write the fact that there's a 2 there because it's always understood that a square root, the index or the root is going to be 2. So we leave it off. So when we're doing these types of problems, this number 3 here, he is called the root. Sometimes you'll hear it called the index number. And then underneath is your radicand. So if we had, say, for instance, the number 10. So the cube root of 10, the fourth root, the fifth root, etc. The rational exponent notation is writing something such as the fifth root of b squared. Well, again, this is our index. I like to call him, he's sitting in a ditch. So my index or my root's in the ditch, and I think of ditch to the denominator. So my radicand comes out with its power, and this is my power. And the root, or the index, that's located in the ditch goes to the denominator. So this becomes b to the 2/5 power. This is my power, and this is my root, or my index. Let's take a look at some conversions. We're going to write these in exponential form, meaning rational. Exponential form. And rational is another way of thinking of a fraction. Fractions are rational numbers. So here we have the third root, or the cube root of 3x squared. So my 3x that's located under the radical sign, he's going to come out. My power, of course, is 2. And the index, or the root number, that's sitting in the ditch comes to my denominator. Now, we must include parentheses because otherwise, if we just left it as 3x to the 2/3 power, this exponent is only applying to the x and not the 3, and that's not what we intend. So that would be an incorrect answer if I wrote it that way. So we have to keep the parentheses there, raising it to the 2/3 power. Let's take a look at our next one. This is the 6th root of 10x to the 5th power. So I can write 10x to the 5th power, but the index or the root in the ditch is going to come to the denominator. So that's how I end up with 10x to the 5/6 power. This is the square root of x, and there's no exponent. So it's assumed to be 1 when there's no exponent, and of course, the square root, we talked about the invisible 2 that sits there, so rewriting this in rational exponential form, this would be x to the 1/2 power. My last one, this time we have a fraction, and in the denominator we have our root. So whenever we have that, we want to bring this up to the numerator. And by doing so, we're going to make the exponent negative. You just can't pull things up there willy-nilly. You have to make sure you have a reason. So this is now to the -2 power. Now, to get rid of my index, we simply write 6r to the -2/3 power. So my index comes to the denominator, and -2. And why did we make that -2? Because it's a positive 2 if it's on the denominator. If I want to pull it up on top of my fraction bar line, I have to change the exponent to a negative number. And there we have it, some examples for you. Let's talk about converting the other way. This time we're going to write each of these as a radical form using a radical symbol. So again, my root, or my index, he goes in the ditch, and then I have 2n raised to the 4th power. Another way you can write it, and you might see it in some textbooks or websites, whoops, how'd that happen? Let's get rid of that, is some people will put in parentheses the cube root of 2n and raise it to the fourth power this way. Either notation is totally fine, whichever you prefer to write it. Let's take a look at another one. We have 3n to the 7th fourth power. Again, my index, or my root, is going to be 4. The ditch goes to the denominator, so the ditch to the denominator. And then I have my 3n raised to the 7th power, or if you're a fan of writing it the other way, oh, sorry, that was supposed to be a 4. The 4th root of 3n to the 7th power. Either way you want to write those. My last one is a negative, so to make a positive exponent, I'm going to drop it down to the denominator, and now it's to the positive 1/3 power. Getting rid of my exponent, I'm going to bring this to the ditch, and I have 7n. Being that it's to the first power, I don't need to put to the first power. Because it's unnecessary. And there we have our answer to that problem. Now we're going to talk about simplifying. Simplifying can be explained in a few different ways. Perhaps when you first learned about simplifying something under a radical, you were taught to use a factor tree. So let's look at 48. And we can multiply two numbers to get 48, and there's different combinations we can use. I'm going to do 6 times 8. 6 is 2 times 3, 8 is 4 times 2. Once they're primed, you just bring them down. 2 times 2, and of course 2. So if we multiplied this row together, it would equal 48. So, being that my index is a 2, if I have a pair of something, I can write it down, and it can come outside. So a pair of 2's, I write one down. Here's another pair of 2's. I can write one down. What's left is my 3. And of course there was only one x. And so to wrap it up, 2 times 2 is 4 square root of 3x. That's one way of doing it. The other way that I can write this, and let me get rid of my factor tree to give us more space, is I can start thinking about those perfect squares. We talked about those when we were factoring. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, etc. You get the point. We can start thinking about some of those square roots. And so I'm looking at my 48, and what comes to mind is we can say this can break down to 16 times 3. That would give me 48, and 16 is a perfect square. So now when I take the square root of 16, I get 4, and of course square root of 3x would remain because neither are perfect squares. So that's another method we can use in order to simplify our radicals. Using the factor tree method, if we look at 32, we think of 4 times 8. This breaks down to 2 times 2, 2 times 4. And if we multiply this all together, we would get 32. Now, once again, if I can make a pair of 2's, I can bring it to outside my radical sign. Here's another pair of 2's, and 1 2 left over, and of course the n, there was only one n. So this would simplify to 4 square root of 2n. Again, if I did it the other way, we're taking a look at what is a perfect square that I can divide 32 by, and I can break that down as 16 times 2 would give me 32, and of course there's an n inside, but as you can see we still get the same answer. Okay. All right, now let's take a look at a little more complicated one. I'm going to get this writing out of my way. Clean up my slate a little bit. And now I'm looking at a negative 80. Well, a negative 80, if I think about it, this is 9 times the cube root. Now, if thinking about my perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. If I start thinking about my perfect cubes, and of course the list goes on, I'm thinking about 8 times 10. 8 times 10. So I'm thinking about a negative 2 times a negative 2 times a negative 2 times 10. And if we think about it, negative 2 and a negative 2, that's positive 4, times a negative 2 is a negative 8 times 10, and that would give us the negative 80. Getting rid of my little chart here. I want to continue on with my m's. And if I were to list them in groups of 3, that would be m to the third times m to the third. Now I've got m to the 6th. I need m to the 8th. That would be m squared. And so now I have this broken down into pieces such that I can circle it and bring it to the outside. So I have 3, pair of 3, so I can bring it out. So 9 times that negative 2. 10 I can't do anything with, it's not a perfect cube, but I've got m to the third, and the cube root of m to the third is m. Cube root of m to the third is m. And that's all I can bring outside. And what's left inside is my 10 and my m squared. So now let's finish it up. If we multiply 9 times a negative 2, that's a negative 18. M times m is m squared, and the cube root of 10m squared, because that is not a perfect cube, so I can't simplify it any further. And this would be my complete answer. 18m squared, cube root of 10m squared. For this next calculation, I want to show you a little trick. I'm going to show you both ways, because I know you're at home, you might not have that graphing calculator, but I told you about Desmos.com. So let me go to Desmos.com. And we're going to launch the calculator. And my next problem was the square root of 294. Now we can certainly do a factor tree, but here's a little trick. The square root, that's the opposite of x squared, isn't it? So I'm going to take 294 and I'm going to divide it by x squared. The opposite of square root is x squared. I'm going to look at the table of values. As I mentioned in class, it's only going to give me 2 numbers on either side of 0, so if I need to continue this on, I'm going to type a 3, and if I just keep hitting enter, it will keep on going. My goal is to find where it ends and where I'm going to have in my y column a number beginning with 0. And as you can see right here, it begins with 0. After that, I'm going to start scrolling backwards. And the first occurrence that I see of a whole number in both columns is going to be my simplification. So here I have 7 and 6. So keep those numbers in mind. We're going to go back to 7 and 6. So where this comes into play is the number on the outside is going to stay outside, and I'm going to multiply that negative 9 times the 7. And then the square root of 6 is going to go on the inside. That's how it's simplified. Now don't forget, we still have to deal with n to the 5th. Now you can use the method up here, like I mentioned to you, how many n squareds can I make? Let's first of all go ahead and multiply this negative 9 times 7, and we get a negative 63. And let's take a look at that n to the 5th. And remember, we have to make squares. So n squared times n squared, well, that makes n to the 4th. We need n to the 5th. I need one more. So let me go ahead and pull out square root of n squared is n. Square root of this, n squared is n. And don't forget we have the negative 63. And what's left is 6n. So my final answer is negative 63 n squared, square root of 6n. And that would be my final answer. Last problem. Now that we've gotten a little messy up here, let me go ahead and clean all this up. And what I'm going to leave you with is the answers to each of these. This was 4 square root of 3x. This problem here was 4 square root of 2n. This problem here we worked out, and we have negative 18 m squared cube root of 10 m squared. This one we had negative 63 n squared, and on the inside we had 6n. Okay, now for my last problem. This time, instead of showing you decimals, I'm going to show you the graphing calculator. Now keep in mind, my index, my root's a 2, the number's 128. So let's go over here. I'm going to type in 128. We're supposed to be taking the square root of that. So I'm going to divide by the opposite. The opposite of square root is x squared. If it was a cube root, I'd be dividing by x to the 3rd power. Hit enter. We're going to look at Control T for the table of values. And we're going to go down until we find a number in this y column that begins with 0. Here it is. And now we're going to start scrolling backwards until we find the first occurrence of a whole number. And here we have 8 and 2. So this square root of 128 is going to simplify to 8 square root of 2. So let's go back to our, so we had a 9 on the outside, and we said 8 square root of 2. Now don't forget we have this x to the 3rd to deal with. And again, we can think about this as x squared times x. That would make x to the 3rd, and the square root of x squared is x. So we now have, we're going to multiply this 72x square root of 2x. So my final answer is 72x square root of 2x, and we're done. One additional thought that I want to share with you, because some people do find it a little bit easier to do it this method, and I'm speaking just about my variables. So let me go to a clean page. Let's say if I'm talking about my variables and I'm finding the 5th root, and say the number is 2, but I've got x to the 12th power. Now, I can write down x to the 5th times x to the 5th, x squared. But remember when we talked about turning things into fractional exponents, in other words, rational exponents, we talked about how we can write this as the 5th root of 2 times the 5th root of x to the 12th. And x to the 12th can be written as x to the 12 over 5. We can simplify this by saying, how many times does 5 go into 12? Well, it goes in there 2 times. So that would be x squared. How many is left over? Well, 5 times 2 is 10. That would leave 2 left over. And then, of course, this 5th root of 2 that we couldn't do anything with would stay. So this would be your final answer if you were working and trying to simplify your variables to a power using the rational exponent method instead. So if that helps you, by all means use that as well. Well, that's it for our video for today. If you have any questions, please feel free to rewind. Of course, write down these notes, bring them in for homework check, and we'll work on some more problems in class. If you have any questions, please see your math teacher and come to CAB Morning. Have a great day.